Hi, here's the detailed solution of 2025 NECO Theory Mathematics, and I'm sure you will gain a lot of value from it. Question 1 is on percentage error, and it says the dimensions of a square is given as 6.25 cm. A student measured one side of the square as 6.12 cm to calculate the perimeter and the area of the square. Find the percentage error in the measured length, the calculated perimeter, and the calculated area. Now, recall that percentage error is actual minus estimated length or whatsoever over the actual times 100%. This is how we calculate percentage error. Sometimes some people can put absolute value here to avoid having negative. So we are given that the actual length is 6.25 and the estimated length by the student is 6.12 cm. So the percentage error, as we have seen here, is the actual 6.25 minus the estimated 6.12 over the actual 6.25 times 100%. If we subtract this, we'll get 0.13 over 6.25 times 100. And if we times this, we'll have, this is 13 over 6.25. If we divide this, this will give us 2.08%. II says, find the percentage error in the calculated perimeter. You want to recall the perimeter of a square. So we'll do the same thing. The actual perimeter, perimeter is the distance around a square, which is L plus L plus L plus L, which is 4L. And so each length for the original is 6.25. So this is 4 times 6.25. Multiply this, we'll get 25 cm. And so the estimated perimeter by the student still use the same formula for L. And so, but this L is estimated length. So this is 4 times 6.12, and this will give 24.48 cm. And next, we are going to look for the percentage error in the calculated perimeter. So using the same formula, percentage error, we use the actual perimeter minus the estimated perimeter over the actual perimeter times 100%. And so the actual perimeter is 25, the estimated is 24.48 over the actual 25 times 100%. If we subtract this, we'll get 0.52 over 25 times 100 over 1. 25 can go 100 4 times, and 4 times 0.52 is 2.08%. Almost the same thing in the perimeter, probably because we are just in one dimension. So let's look at the percentage error in its calculated area. So we'll do again is the actual area. Recall the formula for area is the length square, so L square. And so for the Length, for the actual length, this will be 6.25 square. And if we square this is 39.0.6062 centimeter square. And so the estimated area by the student, same formula, L square, which is the area of a square, will be 6.12 square. If we square this, we'll get 37.45 centimeter square. Now, the percentage error in the area will still be the actual area minus the estimated area over the actual area times 100%, which is 39.062 minus 37.45 over 39.062 times 100 over 1. To subtract this, we'll get 1.612 over 39.062 times 100 over 1. And to multiply this is 161.2 over 39.062. And if we divide, we get 4.126. Let's approximate it as 4.13%. So this is the error the student will make when calculating the area with his faulty length. Question 2 of NECO 2025 is on what problem on algebra? That's simultaneous equation and then exponential equation. It says a factory has 80 employees. If the number of men is doubled and the women tripled, the staff strength would be 190. Find the initial number of men and women working in the factory. So this is our A. So this is how we start. We start with what we are asked to look for. Find the initial number of men and women working in the factory. So we say, let M and F represent the initial men and women. And so from the first sentence, we are told that the factory has 80 employees. That is, the sum of these men and women will make up this 80. This is W. Men plus women equals 80. The next sentence says, if the number of men is doubled, number of men doubled means 2M, and the number of women is tripled. Women tripled is 3W. The staff strength would be 190. 190. Find the initial number of men and women working in the factory. This is just simultaneous equation. So let's use elimination method. Let's call this equation 1, equation 2. Let's multiply equation 1 by 2 so that we can eliminate M to find W. So multiply this by 2. We have 2M plus 2W equals 160. Let's call this equation 3. And so our 2M plus 3W remain the same. 190 equation 2. So at this point, I can subtract equation 2 minus equation 1. Equation 2 minus 3, rather. So this is gone. 3 minus 2 is W. 190 minus 160 is 30. So number of women is 30. So the next thing we're going to look for is the number of initial men. So we'll substitute W equals 30 into equation 1. And equation 1 says m plus w, but we have gotten w as 30 equals 80. And so we can easily get what m is subtract 30 from both sides. And so the number of men is 50. Therefore, the number of men of initial men is 50. B says solve for x if 25 to power 3x plus 2 equals 5 to power 2x plus 1. So what you want to do here is to put this 25 in index of 5 and then use the laws of indices to find what x is. So 25 is same as 5 square, and so this is 3x plus 2. This is 2x plus 1. From laws of indices, we can use product rule such that this power multiply this power, we get 5 is 6x plus this is 4 equals 2x plus 1. From laws of indices, when we have the same base, the powers have to be equal. So we equate the powers. 6x plus 4 have to equal 2x plus 1. Subtract 2x from both sides. This will be 6x minus 2x. Subtract 4 from both sides. This will be 1 minus 4. So this is 6x minus 3x. 2x is 4x. And this is minus 3. And divide both sides by 4 since I'm looking for x. So that my x will be minus 3 over 4. The third question of NECO 2025 theory is on volume of a cone and arithmetic progression. It says the volume of a cone is 565.7 centimeter cubed. If the cone is 15 cm high, find the base radius correct to the nearest whole number. So you want to recall the formula for the volume of a cone. Remember, a cone has height and the base radius. This is what we are looking for. We are given the height as 15 cm and we are given that the volume is 565.7. So volume of a cone we know is 1/3 volume of a cylinder. And so we are given a volume as 565.7. This is 1/3 times 22 over 7 times r square times 15. 3 can go into 15, 5. And so I'm looking for r. I can multiply both sides by 7. So I'll have 565.7 times 7 equals 5 times 22. 5 times 20 is 100 and 5 times 2 is 10. So this is 110. So this is 110 r square. So since we are looking for r square, I divide both sides by 110. So divide both sides by 110 so that r square I'm looking for is 565.7 times 7 over 110. If I simplify this in a calculator, I will get 35.999. And if I take square root of both sides, I'll get 5.999. But we are asked to approximate it to the nearest whole number. So this to the nearest whole number is just the number before the point. So since this is 5 and above, we round up to 1, add it here. So it is 6 cm. This is the radius of this cone with the volume 565.7 cm cube. B says The first, second, and last terms of an arithmetic progression are 1, 4/3, and 3 whole number 2/3, respectively. Find the number of terms in the AP. Now, first of all, what is the formula for n term of an arithmetic progression? The n term of an arithmetic progression is a plus n minus 1 d, where this is the nth term or last term. So this is also called the last term. This is the first term. This is the number of term. This is the common difference. And so we are given the last term as 3 whole number 2/3. We are given the first term. The common difference we can easily get, because common difference is gotten by second term minus first term, or third term minus second term. And from this, it is simply second term minus first term, 4/3 minus 1. And this is 3 times 1 is 3. So this is 1/3. So now, since we know the common difference, we know the first term, we know the last term, we can find what the number of terms is. So the last term is 3 whole number 2/3 equals first term is 1 plus number of term, the common difference is 1/3. And convert this to an improper fraction. This is 3 times 3, 9, plus 2, 11/3 is 1 plus n minus 1, 1/3. I can multiply through by 3, which is the LCM, to clear the fraction. And if I do that, I will have 11, multiply this by 3, I have 3, I have n minus 1 here. 3 minus 1 is 2. I can subtract 2 from both sides. So it will be 11 minus 2 equals n. So the n I'm looking for is simply 9. There are 9 terms in this arithmetic progression, with first term 1, second term 4/3, and last term 3 whole number 2/3. Question 4 of NECO 2025 theory is a problem on statistics, specifically on variance and mean. It says table 4.1 shows the distribution of marks scored by 60 students in an examination. This is the frequency distribution, and we are asked to calculate and correct to 2 decimal places the mean and the variance. So let's get the frequency distribution laid out. So we start with the mark, and then we need to put the frequency. We need to put the value of S, which is the mean of the marks. We need to get Fs that we use to calculate the mean. We need to find the deviation from the mean. We need to calculate its square, and then we need to find F of this. So we can start putting the marks. So we have 1 to 10, 11 to 20, 21 to 30, 31 to 40, 41 to 50. And the frequency are 8, 10, 8, 22, 12. And for us to find what x is to find the average of these two. The average simply means 1 plus 10 divided by 2. So this is 11 divided by 2, 5.5. 31 divided by 2, 15.5. 51 divided by 2, 25.5. You notice just difference of 10. So this will be 35.5 and 45.5. So Fs simply means 8 times this. 8 times 5 is 40. and 8 times half is 4. So this is 44. 10 times 15 is 150, and 10 times half is 5. So 155. 8 times 25 is 200, and 8 times half is 4. So 204. This times this is 781, and 12 times 45.5 is 546. So the next thing we are going to do is to look for our mean, because we need it here. So the summation of f, we already told that they are 60. So this should sum to 60. We have to sum summation of fx. If we sum this together, we'll get 1730. And so we need to find our mean first. And to find our mean, s bar, it is summation of fx over summation of f. And this is simply 1730 over 60. 1730 over 60. 0 can cancel 0. And if we divide this, we'll get 28.833. And to two decimal place, it is 28.83. Two places after the decimal point, because this is not up to 5, we round to 0. That's why it's 83. This to two decimal places. Now, since we have gotten our variance, our mean, we'll get our deviation now. That means 5.5 minus 28.833 minus 23.33. 15.5 minus 28.833 is minus 13.33. 25.5 minus 28.833 is minus 3.33. 35.5 minus 28.833 is 6.667. 45.5 minus 28.833 is 16.667. And so next we'll square. This is 544.288. This is 177.688. This is 11.088. This is 44.448. This is 277.788. Now, if we multiply by f, 8 times this, we'll get 4354.304. 10 times this is simply 1776.88. 8 times this is 88.704. 22 times this is 977.856. 12 times this is 3333.456. If we sum all this together, summation of f of x minus x bar square, we'll get 10531.2. And so to look for the variance, remember the formula for variance. Variance is simply summation of f x minus x bar all square over summation of f. And this we have gotten as 10,531.2 over summation of f is 60. If we divide this, we'll get 175.527. And so to two decimal places, it's approximately 175.53 to two decimal places. Question 5 of NECO 2025 theory is on integral and logarithm without tables. Let's see. Evaluate integral of 4x cubed minus 3x squared plus 2 from 1 to 3. This is what we call definite integral because we'll get a definite answer at the end of the day. So recall that integral of, let's say, x to the power m is simply x, add 1 to the power, and then divide by the power m plus 1. So we are going to apply this for each of these and then apply the limit. So integral of 1 to 3, 4x cubed minus 3x squared plus 2, the x will be, take it bit by bit. This is 4. We'll add 1 to the power and then divide by the power. S 3 plus 1 over 3 plus 1 minus, add 1 to the power, divide by the power. 3x 2 plus 1 over 2 plus 1 plus, if we integrate a constant, a variable will appear. So this is 2x, because x to the power 0 is 1, just plus 1 over 0 plus 1. And so this will give us 4x to the power 4 over 4 minus 3x to the power 3 over 3 plus 2x. Because this is 1 and this is 1. This can go with this can go with this. But don't forget, we're evaluating it from 1 to 3. So this limit is from 1 to 3. From 1 to 3. So this is x to the power 4 minus x cubed plus 2x from 1 to 3. As everything is from 1 to 3. And so let's apply the limit. This will give us, let's put the upper limit first. 3 to the power 4 minus 3 to the power 3 plus 2 by 3 minus the lower limit. Let's put 1. 1 to the power 4 minus 1 to the power 3 plus 2 into 1. So this will be 3 to the power 4 is 81. 3 to the power 3 is 27. 2 times 3 is 6 minus 1 to the power 4 is 1. 1 to the power 3 is 1. 2 times 1 is 2. 81 minus 27 is 54 plus 6 is 60. So this is 60 minus 1 is 0. So this minus is minus 2. 60 minus 2 is 58 square unit. So the integral of this is 58. B says, find the value of x if log 5x minus 6 minus log 2x minus 3 equals 1. So if you notice, there is no base in this log. So whenever we see such scenario, it is assumed as base 10. And so you know from laws of logarithm, when we are subtracting, we divide the number. So this is log 5x minus 6 over 2x minus 3 to base 10 equals 1. So this is same as this. They are equivalent. Now, how we'll find x here is we'll convert this logarithm to indices. There's a relationship that exists between logarithm and indices. And how we do that is this base to this power equals this number. And we do that, it will be 5x minus 6 over 2x minus 3 equals to the base to the power. And 10 to the power 1 is 10. I can cross multiply. I have 5x minus 6 equals 10, 2x minus 3. Let's open the bracket. 5x minus 6. This is 20x minus 30. Let's collect like terms. You can take 20x to the left. We have 5x minus 20x. And then simultaneously add 6 to both sides. We have 6 minus 30. 5x minus 20x is minus 15x. And 6 minus 30 is minus 24. Divide both sides by minus 15. Our x will be minus can go minus. 3 can go. 3 can go here as 8. 3 can go here as 5. Just simply 8 over 5. Question 6 of NECO 2025 theory is on matrices, specifically on determinant and inverse. We are asked that given the matrices A and B, find the determinant of A and the determinant of B, and then find the inverse of A. Let's go. So, determinant of A. So, let's put our A 3, 2, 4, 3, 1, 3, 1, 4, 1. How we calculate determinant is we take this and multiply it by the determinant of what is remaining if we delete the rows and the column of this, minus this times the determinant of what is remaining if we delete the rows and the column of this, plus this times the determinant of what is remaining if we delete this and this. So this plus minus plus. So let's go. So this is 3. Determinant of this is what is remaining. 1, 3, 4, 1. Next is minus 2. Determinant of what is remaining, this. 3, 3, 1, 1. And then plus 4. Determinant of what is remaining. 3, 1, 1, 4. 3, 1, 1, 4. And how do you calculate the determinant of a 2 by 2 matrix? It's just the leading diagonal minus this. 1 times 1 is 1. 4 times 3 is 12. This is minus 2. 3 times 1 is 3. Minus 1 times 3 is 3. Plus 4. 4 times 3 is 12. And 1 times 1 is 1. So for this, we have 3. 1 minus 12 is minus 11. 3 minus 3 is 0. 12 minus 1 is 11. And so this is simply minus 33 minus 0 plus 44. And 44 minus 33 is 11. So 11 is the determinant of A. So for B, let's recall what B is. 4, 2, 3, 1, 5, 2, 2, 1, 4. We do the same thing here. We take this 4 and multiply it by the determinant of what is remaining if we delete this row and this column, which is 5, 2, 1, 4. Next, so this is plus, minus, plus. So minus 2, determinant of what is remaining, if we delete this, 1, 2, 2, 4. 1, 2, 2, 4. Plus 3, determinant of what is remaining, this and this, 1, 5, 1, 5, 2, 1. And so the way we calculate determinant of a 2 by 2 matrix, this minus this. So this is 4. 4 times 5 is 20, minus 1 times 2 is 2, minus 2. 4 times 1 is 4, minus 2 times 2 is 4, plus 3. 1 times 1 is 1, minus 2 times 5 is 10. 20 minus 2 is 18, so this is 4 times 18, minus 2. 4 minus 4 is 0, plus 3. 1 minus 10 is minus 9. 4 times 18 is like saying 4 times 20 is 80, minus 4 times 2, which is 8. So this is 72, minus 0. This is minus 27. 72 minus 27 is 45, because 12 minus 7 is 5, remember 6, 6 minus 2 is 4. So this is 45. That's the determinant of B. Question B says, find the inverse of A. Remember, the formula for inverse of A is the adjoint of A over the determinant of A. That's the formula for inverse. And for us to find the adjoint of A, we need to find the transpose of the cofactor of A. How do we find the cofactor of A? So now, first of all, find the cofactor of A. Now, for us to look for the cofactor of A, we'll do it similarly to how we find the determinant of a 3 by 3 matrix. So, but in this case, we will not add these numbers here, but we will take this round, this minus, plus, minus, plus, minus, plus. So it goes round alternating. So we close this and then take the determinant of this without adding this 3. We'll do it like this without this, and then enter here. We do the same. We block this, we block this, we find the determinant of this. We come here, we block this, we block this, we find the determinant of this. We come here, we block this, we block this, find the determinant of this, without adding this number. This is how we do it here. So we start with this first one, plus 1341, 1341. The next is minus 3311, 3311. The next is plus, block this, 3114, 3114. No, it's a 3 by 3 matrix we need to get. We go to the next, this, we block this and this, we get 2441 minus 2441. Next is this, we block this and this, plus 3411. Next is this, we block this and this, 3214. Next is this, plus, we block this and this, 2441. Next is this, minus, we block this and this, 3433. Next is this, we block this and this, 3231, plus 3231. So let's demarcate this. Let's evaluate the determinant of each of them. This is 1 minus 12. So we have plus 1 minus 12. This is minus 3 minus 3, 3 minus 3. This is plus 12 minus 1. This is, there's minus here. 2 minus 16. This is 3 minus 4. This is 12 minus 2. Sorry, there's a mistake here. This cannot be the same. For this, it's supposed to be 1. We block this and this. 2, 4, 1, 3. So it's supposed to be 2, 4, 1, 3. And so the determinant is 6 minus 4 plus 6 minus 4. This is minus 9 minus 12. And this is plus 3 minus 6. And so if we evaluate this, we'll get our matrix of cofactors. 1 minus 12 is minus 11. 3 minus 3 is 0. 12 minus 1 is 11. 2 minus 16 is minus 14. Times minus is 14. 3 minus 4 is minus 1. 12 minus 2 is 10. Times minus is minus 10. 6 minus 4 is 2. 9 minus 12 is minus 3. Times minus is plus 3. 3 minus 6 is minus 3. Next is to look for the adjoint of A. Adjoint of A is simply the transpose of our cofactor. The cofactor is C, to be C transpose. So we call this as our cofactor. So our adjoint of A is the transpose of this. So it is simply, and transpose is the rows become the column. The rows become the column. The rows become the column. So this is minus 11, 0, 11. This is 14, minus 1, minus 10. This is 2, 3, minus 3. Then the next thing is to find the inverse of A, which is adjoint of A over determinant of A. And this is simply dividing this or multiplying this by 1 over the determinant of A. And we have gotten determinant of A as 11. So this is 1 over 11 times minus 11, 14, 2, 0, minus 1, 3, 11 minus 10, 3, minus 3. So if we multiply this, we'll get, this will be minus 1, this will be 14 over 11, this will be 2 over 11, this will be 0, this will be minus 1 over 11, this will be 3 over 11, this will be 1, this will be minus 10 over 11, this will be minus 3 over 11. So this is what the inverse of A is. If you want to check if it is correct, if you multiply this with A, you should get the identity matrix. Question 7 of NECO 2025 theory says, use completing the square method to solve the equation. So it's just trying to say, use the method of completing the square to derive the quadratic formula. Let's see how it goes. So if we have the quadratic equation ax squared plus bx plus c equals 0, the first thing you want to do is to divide through by the coefficient of x squared. And if we do that, we'll have x squared plus b over ax plus c over a equals 0. The next thing we'll do is to take this constant term to the right hand side, and we'll have x squared plus b over ax equals minus c over a. You know, if we take a number across the equal sign, it changes to the opposite sign, which is minus. Now, the next thing is crucial. It is to look for the coefficient of x, which is b over a, and take half of it, which is b over 2a, and square it. So and then add it to both sides. So in excess, you are adding half the square of the coefficient of x to both sides. So let me just write it. Add half the square of the coefficient of x, which is b over 2a all square. And if we do that, we'll have x squared plus b over ax plus b over 2a all square equals minus c over a plus b over 2a all square. This is where the completing the square is. So by adding this to the left hand side, this is now a perfect square. That means I can factorize this as x plus this in bracket b over 2a all square, and this is simply, if I open this bracket, I have minus c over a plus b square over 4a square. Now I can simplify this and we'll have x plus b over 2a raised to power 2. If I take this first, this is, and the LCM is 4a square. If I write this first, this is what I have, 4a square. If 4a square get to 4a square, you get 1. Multiply b square, you have b square minus a into 4a square is 4a times c is 4ac. And so at this point, I can take square root of both sides. If I take square root of both sides, I'll have x plus b over 2a. Square root of this, we cancel this square. We'll have plus and minus, because if you take square root of a number, you either get the plus and the minus of that number. Square root of b square minus 4ac over 4a square. Now, I cannot take square root of this easily, which is the numerator, but I can take square root of the denominator. If I take square root of this, this is 2a. And so I can subtract b over 2a from both sides. I will get x equals minus b over 2a plus and minus square root of b square minus 4ac over 2a. Now, since the denominator are the same, we can easily add and subtract the numerator. Therefore, the x we are looking for, the two numbers, will be minus b plus or minus square root of b square minus 4ac, everything over 2a. This is that quadratic formula you usually use to solve quadratic equation. And this is what we are asked to look for. Next, we are asked to use this result to find the root of this quadratic equation. So for us to use this, we need to know what a, b, and c is. So in this case, a is 4, b is 7, c is minus 2. And so we'll substitute this into this, and then we'll get what our two roots are. So that x1, 2 will be minus b, our b is 7, minus 7 plus or minus square root of b square. 7 square is 49 minus 4ac. 4 times a. 4 times 4 is 16 times minus 2 is minus 32. But there's minus here. So it will be plus 32. So this is plus 32, everything over 2a. 2 times 4 is 8. And so we can simplify this as minus 7 plus or minus 49 plus 32. 40 plus 30 is 70. 9 plus 2 is 11. 11 plus 70 is 81. So this is square root of 81 over 8. But square root of 81 we know is 9. So that our x1, 2 will be minus 7 plus or minus 9 over 8. If we simplify this, we'll take the plus first and then take the minus. This is same as minus 7 plus 9 over 8, or minus 7 minus 9 over 8. And if we simplify this, this will be minus 7 plus 9 is the same as saying 9 minus 7, which is 2. 2 over 8, which is 1 over 4. Or minus 7 minus 9 is minus 16. And so this is minus 16 over 8. And then this is minus 2. So x1 is 1 over 4. X2 is minus 2. These are the roots of this quadratic equation. 7b says the mean of 6 numbers is 40. 3 of the numbers sum up to be 90. What's the mean of the remaining 3 numbers? This is an interesting question. Recall the formula for mean that says x bar equals sum of the numbers over how many numbers are there. So let's assume the 6 numbers are A, B, C, D, E, F. And so you remember how we find mean? We sum this A to F and then divide by 6. So this is A plus B plus C plus D plus E plus F. Everything over 6. However, we're told that 3 of the numbers sum up to be 90, whereas the mean of the 6 of them is 40. So the mean is 40, but 3 of them, let's assume the 3 are A, B, C, sum up to be 90. Not the mean of 3 of them, but the 3 of them sum up to be 90. So if A plus B plus C is 90, so let A plus B plus C be the one that are 90, that is 90. So we have 90 plus D plus E plus F over 6. Next we'll do is multiply. Okay, I can divide this directly. I have 40, 90 divided by 6 is 90 divided by 6 is 15 plus D plus E plus F over 6. I can subtract 15 from both sides, and then I'll get 40 minus 15 is 25. D plus E plus F over 6. But what are we asked to look for? What is the mean of the remaining 3 numbers? Remember, if we are to find mean of 3 numbers, it will be the sum of the 3 numbers over 3. So since we have 6 here, it's cool to multiply both sides by 2, just to have 3 here. So if I multiply both sides by 2, 2 times 2, 2 will go into 6, 3, so that this will not be mean of 3 numbers. And then 50 will now be the mean of D plus E plus F over 3. This is what we are asked to look for. The mean of 3 numbers is 50. Question 8 of NECO 2025 theory says, calculate the area of the shaded portion. That's this part. So you want to ask yourself, what shape is this? This is a sector. And to calculate the area of this shaded part, you need to find the area of this sector minus the area of this triangle. That will simply give you the area of the shaded part. Let's go. Area will be area of sector minus area of triangle. Recall the formula for area of sector is theta over 360 times pi r square minus area of triangle with included angle is given as 1 over 2 r square sine the included angle. To make things easier for us, we can factorize this arrow square or factorize arrow square over 2. We'll have arrow square over 2 bracket pi arrow or pi theta, because arrow square is at, over this is 180 minus sine theta. So our arrow is 8, this is 8 square over 2, and our pi is, since we're not giving pi, is okay to take pi as 22 over 7. So this will be 22 over 7 times our theta is 54. 54, we have 180 here, minus sine 54 degrees. 8 square is 64, and 2 can go 64 as 32. I mean, 2 here is 11, 2 here is 90. 9 can go here, or rather 18. 18 here is 3. 18 here is 5, because 18 times 5 is 90. So what we have left is 33 over 35 minus sine 54 degrees. And so if we use calculator on this, we'll have 32 times 0.13384. And then if we multiply this, we'll have 4.282. And we can leave this in one decimal place as 4.3 centimeter square. This is the area of this shaded portion. B says a tin of milk has a radius 6.5 cm and height 13 cm. Find correct to 2 decimal places the total surface area of the tin. Recall that a tin is a cylinder, and so the height of the tin is 13 cm and the radius is 6.5. What's the total surface area of a cylinder? Total surface area of a cylinder is the curved surface plus the total surface of the base and the top. So the curved surface is 2 pi arrow h plus the total surface of the top and the bottom, which is a circle, is pi arrow square plus pi arrow square, which is 2 pi arrow square. To make our life easier, we can factorize 2 pi arrow out. We'll have 2 pi arrow bracket h plus r. So we're asked, we can take pi as 22 over 7. So this is 2 times 22 over 7 times 6.5 bracket 13 plus 6.5. And so this is 44 over 7. Let's multiply this in our calculator. So this is 44 times 6.5 over 7 times, this is 19.5. If we do this on our calculator, we'll get 796.714. But we are asked to approximate it to 2 decimal places, and 2 decimal places means 2 digits after point. So 1, 2. Since it is not up to 5, it is approximately 796.71 centimeter square, since it's just surface area. The next says, find the volume of liquid in liters that will fill the tin. So we can find it in centimeter cube and then convert it to liters. What's the volume of a cylinder? The volume of a cylinder is given as pi arrow square h, meaning the base area times the height. That is how we usually calculate the volume of a 3D shape. The base area times the height. So what's the base area? It's a circle. So this is 22 over 7 times 6.5 square times 13. If we do this on our calculator, we'll get 1726.214. But we are asked to leave it in liters. Recall that 1 liter equals 1000 centimeter cube, because our answer is in centimeter cube. And so x liter will give us what? Will give us 1726.214. We're looking for how many liters will give us this. So if you cross multiply, we'll have x to be 1726.214 divided by 1000. And this is just to move the decimal point 3 places back. So this is 1, 2, 3. So this is 1.726214. And to 2 decimal places is approximately 1.12. Since this is up to 3, we round up and add here 73 liters. Question 9 of NECO Theory 25 is on bearing, and it says an aircraft took off from an airstrip with an average speed of 35 km per hour on a bearing of 15 degrees for 2 hours. It then changed course and flew on a bearing of 100 degrees with an average speed of 22 km per hour for another 2.5 hours. Find its distance from the starting point to 2 decimal places. Now notice that we are given the speed and the time, but we are asked to look for distance. So it will be appropriate if we calculate the distance from the speed and time we know, and then use it with the diagram to determine the distance from the starting point to 2 decimal places. Recall that speed equals distance over time, and if we call the first journey d1, it means for 35 km per hour, the first distance over 2 hours. So d1 will be 70 kilometers. And for 22 km per hour, the second distance, this is 2.5. So d2 will be 55 kilometers, because 2 times 22 is 44, and half times 22 is 11. 44 plus 11 is 55. And so with this, we can now sketch the journey. It starts on a bearing of 0.15 degrees. So this starting point will help you know how to draw. So since 15 degrees we go up, you want to put it at the bottom here. So it looks like, okay, let's sketch it here. So it looks like this is our North Pole. And so this is our North Pole. 15 degrees will be in this direction. And then after getting to this point, it took another journey for 100 degrees. Remember, this is 90 degrees. 100 degrees will be in this direction. So this is 0, 15 degrees. So 100 degrees will be around this direction. But it will not go too far because this is 55 kilometers and this is 70 kilometers. And so let's draw our pole. If you are unable to sketch this, it will be difficult to answer this problem accurately. So that when we join this, we have formed a triangle. Now we are asked to look for, at the first question, this distance. Let's call it D3. Now, how do we get this included angle? If this is 15 degrees and this is 100 degrees, you know angle on a straight line is 180, and so 180 minus 100, so this little one here will be 80 degrees. Because this is 15 degrees, of course, this will be 15 degrees too. We call it alternate angles. So this is 15 degrees. So the whole of this angle will be 15 plus 80, which is 95 degrees. Now, to get this third distance is easier using cosine rule, because if we know two sides and an included angle, we can use cosine rule to find what D3 is. D3 is simply the square root of the first distance D1 square plus D2 square minus 2 times the first distance, second distance, cos the included angle. This is, the first distance is 70 square plus 55 square minus 2 times 70 times 55 cos 95 degrees. And so if we take the square of this plus the square of this, we will get 7925. And if we subtract this product, we will get minus 671 plus 0.099. If we add this, this will be 7925 plus 671.099. This is square root of 8596.099. And if we take square root, we have 92.715. And we are asked to approximate it to two decimal places. Two decimal places simply means after decimal point, two places. This is up to 5. We round it up. 92.72 kilometers. So this is the distance from the starting point. The second part said, find the bearing from the S strip to the nearest degree. This distance, find this bearing from the S strip to this. So if we call this theta, if we can find theta and add it to 15 degrees, that's the bearing at this final destination from the S strip. And so to get what theta is, since we know this side and we're looking for this angle, and we have gotten this and we know this side, we can use sine rule. Sine rule says A over sine A equals B over sine B. And so if we use that here, let's call this A. So this is 55 over sine theta equals B, which is this D3, 92.72 over sine B, which is sine 95. And so to find what theta is, we can cross multiply. 92.72 sine theta will give 55 sine 95. And then sine theta will be 55 sine 95, everything over 92.72 0.72. Then if we divide this, sine theta will be 0.5909, and then theta is taking sine inverse. This is 36.22, approximately 36 degree to the nearest degree. B part says differentiate 1 plus x multiplying 1 plus 2x squared over x with respect to x. There are so many routes we can use for this. We can try to use the quotient rule since this is a rational function. We can try to use the product rule by dividing each either of these two by this, or we can try to open the bracket and then use differentiation directly by differentiating each of the algebraic term. So let's do the third one, which is much easier. So if I divide this, I will have, let's call this y. I have 1 plus x. If I divide this by x, I will have 1 over x plus 2x. If I open the bracket, I will have, this is 1 over x plus 2x. This is plus 1 plus 2x squared. Now, if I want to differentiate the y, the x, recall that if y is x to power n, the y, the x is this power multiplying this n times x. You subtract 1 from the power, which is n minus 1. This is what we use to differentiate this. And if we have a constant, if we differentiate it, it's always 0. So I can rewrite this. 1 over s is the same as s to power minus 1. And so this multiply this, subtract 1 here. So this is minus s to power minus 2 plus, if I differentiate this, the power here is 1. Multiply this, this is 2. Subtract 1 here. 1 minus 1 is 0. And so x to power 0 is 1. So this is 2. This is 0 because it's constant. And this is 2 times 2, 4. 4x, subtract 1 here to power 1. And so if we rearrange, the y, the x will be, let's start with the constant, 2 plus 4x minus, this is same as 1 over x squared. That's the answer of the differentiation of this rational function. Question 10 of NECO 2025 is on construction, which is one of the topics I love so much. And it says, using a ruler and a pair of compasses, just have only a ruler. The pair of compasses will figure it out without it, but you'll be guided. Construct triangle PQR. So that tells you that what we are constructing is a triangle, such that line PQ is 8 cm. So it's usually good to sketch what you want to construct, so that instead of looking at the question while constructing, you are looking at your sketch to make your work easier and neat. So construct triangle PQR such that PQ is 8 cm. So usually put the length at the base. Let's call this PQ 8 cm. Angle arrow PQ 120. Arrow PQ means the angle is here, and 120 degree is bigger than 90. So this will look like this. So this is 90 degrees, and this is our arrow. And then angle PQR at Q is 30 degrees. I know 30 degrees is an acute angle, less than 90. So it is this. So this is 30 degrees. And the first thing we have to look is the locus LO1 of point equidistant from P and Q. Equidistant means construct a straight line that is equal distance from P and Q, meaning that divides P and Q into two equal parts. So if this is the midpoint of P and Q, so you are constructing something that looks like this. You have to construct it. You don't just draw it as a straight line. You have to construct it using pair of compass. And next, this is L1. The locus L2 of point equidistance from PQ. This is PQ and P arrow. which passes through the triangle PQR. So the locus of point that cut two lines is an angle, is bisecting an angle. The locus of point that is equidistant between 2 points is a straight line that passes through the point, but that passes through the intersection of two lines is bisecting this angle. So while we are bisecting this line, we're going to bisect this angle, which is, this is 90, so we're going to bisect it to 45, make it equal, and then this will look like this. Mind you, we're not doing anything perfect here, we're just trying to sketch. So this is our LO2. And next says the locus LO2 of point, okay. B says label the point where LO1 and LO2 intersect as X. This is X. And then measure QS. So measure this distance. That's all. So next we are going to be looking at this to construct. The first thing you want to do is to measure 8 cm from your ruler. So measure 8 cm. How you do that is you draw a straight line, you use your pair of compass and measure 8 cm on your ruler, and then cut. So this is P, this is Q, and this is 8 cm. The next you want to do is to construct this angle. This is 120 rather, this is 120. To construct 120, how we construct 120 is you put your pair of compass here, you take your radius of any choice, but not too big, and then you draw an arc. Without adjusting the radius, you place your point here and then cut. This angle here is 60, while this angle here is 120, which is what we are constructing. So you draw it out 120 degrees. So this is 120 degrees. We are not told where this will stop. It is the angle we construct here that will determine where this will stop. And so this is our R. Next is to construct this angle 30 degrees. Almost the same way we constructed this. And so what we will do is to construct 60 and bisect 60. Because when you bisect angle 60, you get 30. And so you put your point here of your pair of compass, you take any radius of your choice, and then draw an arc. Without adjusting it, you place your point here and then cut. This is 60. How do you get 30? So you place your pair of compass here and cut. You place your pair of compass here and cut. When you join this line together, this gives you 30. So this is this is here our arrow is. And this is 30 degrees. So the next thing you want to do is to find the locus L1 of point equidistant from P and Q. So the locus L1 of point will be at the middle here. So what you do is you take your pair of compass, you stretch it, place it here, and cut. Without adjusting it, you cut at the bottom, and then place it here too, and cut. Without adjusting it, place it here and cut. And then join these two together. This will be so this is our L1 of point. The second is the locus LU2 of point equidistant from PQ and PR. So it's to bisect this. What we do is we place the point here and then cut, and then place it here and then cut, and then stretch it out from this point. This is how we bisect angle 120. So this is, can stretch it out. This is our LU2 of points. And then they say we should label here where they meet as X and then measure QS. So look at what we are measuring. At the end of the day, if we measure this QS, what we have is 4.7. So measurement QS is 4.7 cm. And that's what we are asked to do. Question 11 of NECO 2025 theory is on graphical solution of a quadratic equation. And it says copy and complete this table for y equals 2x squared minus 4x minus 3. And then use a scale of 2 cm to 1 unit on x-axis and 2 cm to 5 unit on y-axis. Draw the graph of y equals 2x squared minus 4x minus 3 for x values ranging from minus 2 to 6. And then use your graph to find the roots of the equation 2x squared minus 4x minus 3 equals 4. Correct to 1 decimal places, and then the gradient of the curve y equals 2x squared minus 4x minus 3 at x equals 4. So let's copy and complete this table. So to find what y is simply to substitute minus 2 for x here. So minus 2 squared is 4 times 2, 8. Minus 8 is 16. 16 minus 3 is 13. We already know this. If we put 0 for x, we only have minus 3. And if we put 1 for x, this is 2 minus 4, which is minus 2. Minus 3 is minus 5. We already know this. If we put 3 for x, this is 9 times 2, 18, minus 4 times 3 is 12. 18 minus 12 is 6, and 6 minus 3 is 3. If we put 4 for x, we'll have 16 times 2, 32, minus 16, which is 16, minus 3, which is 13. And then if we put 5 for x, 5 square is 25 times 2, 50, minus 20, 30, minus 3, 27. So the next thing we want to do is to sketch the graph. Use a scale of 2 cm to 1 unit on x-axis and 2 cm to 5 unit on y-axis. And so if you notice, you will observe that our x ranges from minus 2 to 6, meaning we have more values at the right hand side of x than at the x. So this will help us tilt the center line to the left. And on the y-axis, we have more positive values, which is 45, than negative values, which is minus 3. That means we have to tilt the horizontal line to the bottom. So the vertical line to the left, because of more x values, positive x values than the negative, and the horizontal line to the bottom because of more positive y values than negative y values. Let's see how it goes. So just like I said, we can tilt it here. So because of the y values, we have more positive y values. So it's sufficient to put it here. And so let's start putting our point. 2 cm to 1 unit on the x-axis means for every 10 small boxes is 1. So if this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For every 10 smaller boxes is 1. So we'll do the same thing. This is 2, do the same thing. This is 3, do the same thing. This is 4, do the same thing. This is 5, do the same thing. This is 6. Likewise here, this is minus 1. This is minus 2. Then 2 cm to 5 units on y-axis. Similar thing, for every 10 smaller boxes, we have 5, 10, 15, and likewise. For every 10 smaller boxes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 5 here, 10, 15, 20, 25, 30, 35, 40, 45. So with this, we can plot our quadratic graph. So we start with minus 213. So for the x-axis, each box is 0.1. For the y-axis, each box is 1 over 2, 0.5. How do you get that? 5 over 10 boxes. 5 over 10 is 0.5. And for the x-axis, 1 over 10 is 0.1. So for us to get 13 for minus 2, this is 10. Each box is 0.5. So 10, 10.5, 11, 11.5, 12, 10, 12.5, 13. So this is where our point is. For minus 1 is 3. Like I said, each box is 0.5. So this is 1, 2, 3. So for minus 1, we have 3. For 0, we have minus 3. So this is minus 5. Minus 3 will be at this point. For 1, we have minus 5. For 1, we have minus 5. For 2, we have minus 3. For 2, we have minus 3. For 3, we have 3. For 3, we have 3. So each box is 0.5. 1, 2, 3. For 4, we have 13. For 4, we have already gotten it before. We have 13. For 5, we have 27. For 5, we have 27. This is 27. For 6, we have 45. For 6, we have 45. So what we have next is to join these points together. So we can start from here. Just pass through the midpoint. And then you don't want to make it a straight line but curve. So this is the graph we are asked to construct. Then CII says use your graph to find the roots of the equation 2x squared minus 4x minus 3 equals 4. This 4 is where y is 4. So we look for where y is 4, which is this, and then draw a horizontal line. So it's just a little bit above where it is 3. So this is a little bit above where it's 3. And then join this here. Remember I said each box for the x-axis is 0.1. And so this is simply for I, our value of x, the root, is minus 1.2 and 3.1. For II, we have to look for the gradient of 2x squared minus 4x minus 3 at x equals 4. Remember, gradient is y equals y2 minus y1 over x2 minus x1. Sorry, this is m. M equals y2 minus y1 over s2 minus x1. But at the point s equals 4, where is the point x equals 4? This is x equals 4. To find the gradient is just to, we can use two values that we know. So we can sketch this, draw a straight line that passes through this point, and then draw this. Let's stop at this point that is already known. So that this is simply this point minus this point. This is our y2. This is our x2, y2. This is our x1, y1. So this point is at s equals 5, 27 minus at s equals 3 minus 3 over, this is 5 minus 3. This is simply 24 over 2. This is 12. To confirm that your answer is correct, if we were to find the gradient of this curve, it's just simply differentiate this and substitute f equals 4. So the y, the x, is simply 4x minus 4. If you substitute s equals 4, at s equals 4, we have 4 times 4 minus 4. This is 16 minus 4, and this is 12. So this is the correct answer of the gradient. Question 12 of NECO 2025 theory is on cumulative frequency distribution. And we are asked to use this table to construct the cumulative frequency for the distribution and draw the cumulative frequency curve. and then use the curve to find the median, the 70th percentile, and determine the mode of the distribution. So the first thing we want to do is to get the cumulative frequency table. So A, we need the max, we need the frequency, we need the cumulative frequency, CF, and then we need the class boundary. So for the max, we have 40 to 44, 45 to 49, 50 to 54, 54, 5 to 59, 60 to 64, 65 to 69, 70 to 74, 74 to 79. For the frequency, we have 3, 5, 8, 11, 9, 7, 5, 2. Cumulative frequency is simply adding this cumulatively. So we start with 3. 3 plus 5 is 8. 8 plus 8 is 16. 16 plus 11 is 27. 27 plus 9 is 36. 36 plus 7 is 43. 43 plus 5 is 48. And 48 plus 2 is 50. And then the class boundary is simply 0.5 lower than this and 0.5 above this. So this is 39.5 to 44.5, 44.5 to 49.5, 49.5 to 54.5, 54.5 to 59.5, 59.5 to 64.5, 64.5 to 69.5, 69.5 to 74.5, 74.5 to 79.5. Then the cumulative frequency is 50. Summation of F is 50. Now, for us to plot the cumulative frequency curve, we will need this upper class boundary with this cumulative frequency. Since it terminates at 50, we'll sketch. So we are plotting the upper class boundary against the cumulative frequency. So since it's up to 50, we can take 2 cm or 1 cm to 5 units. So this is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And for this, we have 45 to 79. Since we did not start from 0, we can just do this and then start counting. 45, 44, 49, 54, 59, 64, 69, 74, 79, 84. So this is 44.5, 49.5, 54.5, 59.5, 64.5, 69.5, 74.5, 79.5, 84.5. Now we can start plotting. So we are plotting the upper class boundary with the cumulative frequency. So at 44.5, we have 3. So for 1 cm, 1 unit, each box is 1. So 3 will be at this point. So we have this. At 49.5, we have 8. 8 will be at this point. At 54.5, we have 16. 16 will be at this point, a little bit above 15. At 59.5, we have 27. 27 will be at this point, a little bit above 25. At 64.5, we have 36. 36 will be a little bit above 35. At 69.5, we have 43, which will be a little bit about 43, 40. At 74.5, we have 48, above 43. And at 79.5, we have 50, which is our final point. And then we join the curve. So the curve goes like this from the origin and then it curves out. So this is the frequency, cumulative frequency distribution. We are asked to look for the median. To find the median, we first of all find the median class. The median class is to divide the whole frequency by 2. Median class, it is n over 2, which is 50 over 2, which is the 25th term. So how do we get the 25th? We take this and then find where 25th is. Which is about 58.5. So the median is 58.5. And then the 70th percentile. The 70th percentile is simply 70 over 100 times the total frequency, 50. This is 2, and 2 into 70 is the 35th term. Meanwhile, the median class is at the 25th term. The 25th is above this, which is this. So this is where the median class is. This is the median class. So the 35th term, the same thing we did. This is 35th. We sketch. And then we connect to the x. So this is like, so the 70th percentile is like 63.5. And then the mode the formula for mode says the lower class boundary plus delta 1 over delta 1 plus delta 2, this times the class interval. So LO1 is the lower class boundary of the modal class. Remember, mode is the max with the highest frequency. If we check the frequency, the highest frequency is 11. So the lower class boundary of the modal class is 54.5. That is LO1. So this is 54.5 plus delta 1 is the difference between the modal class and the frequency before the modal class. So this is 11 minus 8 over delta 1, the same thing, the frequency of the modal class and the frequency before the modal class. 11 minus 8 plus delta 2 is the frequency of the modal class and the frequency after the modal class. 11 minus 9. And then we multiply this by C. C is the class interval. The difference between this and this is simply 5. So if we simplify this, we'll have 54.5 plus 11 minus 8 is 3. This is 3 plus 2 is 5 times 5. So if we add this, this is simply 57.5. This is the mode of this problem. Thank you for watching. Make sure you like, subscribe, and share. See you in the next video. Bye.